Hi gradettes, we're on to topic 2. So topic 1 was all about the definitions that we need around fractions and our basic skills like converting and equivalent fractions, and now we can actually start working with them a little bit. Now this topic should be something that you're fairly familiar with, and that is addition and subtraction of fractions. Don't forget right throughout this video to hit pause and to write down the notes. It's really important because we don't really study fractions again, and yet we have to work quite extensively with them. So it's important for us to have good notes. So the first thing that I'd like us to take down is the golden rule of adding and subtracting fractions. Now, really important is that people think that you have to use this golden rule for everything with fractions, and that's not true. It's only for adding and subtracting, and that rule is you can only add and subtract fractions when you have the same denominator. So let's write that down. You can only add and subtract fractions when you have the same denominator. So really, really important. It's only true in adding and subtraction. So when we do multiplying and dividing, we don't have to worry about this, and we'll talk about that later. So only when you add and subtract fractions, you have to have the same denominator. Very, very, very important. Now, there's an important reason as to why this is true. If you don't have the same denominator, how are you going to add parts of a whole together? If you have, for example, a third plus a half, you're not adding the same size piece, and you can only add the pieces together to find out how many pieces you have if you're talking about the same size piece. So you can only add and subtract fractions when you have the same denominator. So let's look at a couple of examples. So example 1 is a picture of how we do it. So this picture says if you take a whole and you have 5 pieces out of 7, so you'll notice there's 1, 2, 3, 4, 5, 6, 7 pieces in the whole, and I have highlighted 5, so that would be 5/7 of that whole. The next picture again has 7 pieces, 3, 4, 5, 6, 7, because otherwise you wouldn't be adding the same sizes together. However, here I've only highlighted 4 of them. Now when you add them up, if I use some color here, basically this is 1, 2, 3, 4, 5 from here, and then we had 4 extra from the second group. So 1, 2, 3, 4. Now because we had 5, but the whatever this is, a cake or a bar of chocolate, is divided into 7 pieces, 2 pieces were needed to complete the whole. So that's why I have 1 whole, and then there's 2 leftovers. So 1 whole and 2 parts out of 7 in the next bar of chocolate, for example. Now I must say, I've said this before, we don't like mixed numbers, so you can write 1 and 2/7. Personally, what we would do is write 9/7, because we would say, right, I have 5 pieces plus 4 pieces, so I have 9 pieces, and these pieces are still 1/7 of a bar. So note, my denominator does not change, because you're not dividing the cake up into any more pieces. Remember, your denominator is how many pieces the cake or the bar of chocolate is divided into. So you're not dividing the cake up into any more pieces, you're just adding pieces on. So note that we add the numerator, but we leave the denominator the same, because you're simply counting up how many pieces you have, but you haven't divided the cake into any more pieces. Now, this worked because they were the same denominator. So very importantly here, I made this example where they had the same denominator, and so I was able to add them because I was adding the same size pieces together. In our next example, what happens if they're not the same denominator? Now, if they're not the same denominator, our first step is we need to convert each fraction into an equivalent fraction, but with the same denominator. So each of these fractions, we need to convert each fraction to a fraction with the same denominator. Now, it must be an equivalent fraction, because I don't want to change the meaning of the question. So if I have a look at this step basically means an LCD. Now, it doesn't have to be a lowest common denominator. You can always be any common denominator, but then you're going to have to simplify your answer in the end. So to avoid making our lives more complicated, we would say to ourselves, what is the lowest common multiple or the lowest common denominator of 3 and 6? So what is the smallest number that 3 and 6 both go into? And that answer is 6. So I'm going to convert each fraction to a fraction out of 6. and then my final answer will be a fraction out of 6. Remember, you don't add the denominators. You're not dividing the cake into more pieces, so we do not add the denominators. You're not changing the size of the pieces, you're just calculating how many you have. So do not add the denominators. So now I need to convert each fraction to a fraction with a denominator of 6. Fortunately, the second fraction already has a denominator of 6, so that's 1. But this first fraction we've done converting in the previous video. So what do you have to multiply 3 by to get to a denominator of 6? That's 2. But what you do to the bottom, you must do to the top, so that effectively you're multiplying by 1. So you're rewriting that fraction, but it means the same thing. So that's 4 pieces out of 6 would be the same thing as 2 pieces out of 3. And then basically I just add my numerators. So 4 plus 1 is 5. So if I just write myself a note there, we don't add the denominators, we just add the numerators. Now this should be very familiar to you. I would definitely still write down these notes because I think we get confused as we go further along. But this should be something that you're quite familiar with. Okay, let's look at some more examples. Example B, well, our denominators are 3 and 4. So my first step is, what would be the denominator of 3 and 4? If you're desperate, you can just multiply them together. Now, I'm pretty sure all of us know that 3 and 4's lowest common denominator is 12. So I'm going to have to convert the first fraction to a fraction out of 12, the second fraction to a fraction out of 12, and my answer will be a fraction out of 12, because remember, I do not change the denominator. So I'm going to say to myself, let me erase that, what do you have to multiply 3 by to get to 12? I have to multiply by 4, so I must multiply the top by 4. So effectively I'm multiplying by 1. So 2 times 4 is 8, so 8 pieces out of 12 is the same as 2 pieces out of 3. I have to multiply 4 by 3, so I must multiply the top by 3, and I get 3. And finally I'm going to add my numerators, and 8 plus 3 is 11. Now something that's really important, don't forget that sometimes we will need to simplify the answer. So always check that your fraction answer is the simplest form. So check that the answer cannot be simplified further. So I should always say to myself, is there anything that goes into 11 that also goes into 12? Now the nice thing is you could just cheat on your calculator and put in the fraction 11 over 12, push equals, and it'll tell you if that's the simplest version, because it'll say equals 11 over 12 if it is the simplest version. Otherwise it'll simplify for you. So it's a good check. I know that this won't simplify because 11 is a prime number. And so the only thing that goes into 11 is 1 and 11. And 11 does not go into 12. So my answer is 11 twelfths. Okay, now subtraction is exactly the same concept except you're subtracting. So this particular example 3, please make sure you draw these pictures. But basically the first fraction said 5 pieces out of 7, so 1, 2, 3, 4, 5, and I'm taking away 3 of those pieces. So it's almost like take away that one, take away that one, take away that one. What are you left with? I'm left with 2 pieces out of 7. So again, you basically just subtract the numerators because you're counting up how many pieces I have. Notice if these pieces aren't the same size, I can't do anything. So they have to have the same denominator, but notice you do not subtract the denominators because you're not changing the size of the pieces. So the denominator stays the same. So it's exactly the same as addition, except you're subtracting the numerators and not adding them. So again, let's try some examples together. Example number 4, simplify without a calculator, and the steps are going to be exactly the same. Convert each fraction to an equivalent fraction with the same LCD. So convert each fraction to an equivalent fraction, meaning the same meaning, equivalent fraction with the same denominator. So again, I need to focus on an LCD. So this is where your multiples are really, really helpful. So this means LCD. And here we go. What is the LCD? What is the lowest common denominator of 8 and 3? Well, let me just check. 8 is 8 and then 16. 3 doesn't go into 16. And then 24. Now I know that 24 is going to work because 8 times 3 is 24. So that means I'm going to convert the first fraction to a fraction over 24, the second fraction to a fraction over 24, and then my answer is going to be a fraction over 24. So it's exactly the same logic. My denominator does not change. So now I need to convert 8 to 24, so I need to times by 3. But what you do at the bottom, you do to the top, because then effectively you're multiplying by 1, and so 1/8 means the same thing as 3 over 24. Now I'm going to multiply 3 by 8 and 2 by 8, so I get 16. So 16 out of 24 is exactly the same as 2 out of 3. And now I just subtract the tops. Now, and up until now we haven't been dealing with integers and fractions, and so in primary school you would never have something where the tops subtract to a negative. Now there's no problem with that. 3 take away 16 is actually negative 13. Now there's nothing wrong with having a negative fraction. We don't always write the negative at the top. You can write it next to the fraction, but we never write the negative at the bottom. So either with the numerator or just next to the whole fraction. So just to write myself a note here, I basically just subtract the top and I keep the denominator the same. So I don't subtract my denominator. So exactly the same logic as addition of fraction. So denominator stays the same. Okay, let's try some more. Question B. Exactly the same idea. Can I convert these to having the same denominator? Well, the LCD of 9 and 3 is pretty easy, because that will be 9. 9 goes into itself and 3 goes into 9, which means my answer will be out of 9. Now what I'm going to do is I'm going to say to myself, well, 4 over 9 is just 4 over 9. What do I have to do to 3 to get to a denominator of 9? I must multiply by 3, and 2 times 3 is 6. And now I can subtract the tops, because 4 take away 6 is negative 2. Feel free to use your calculator if you're not good with your integers. Also, always check these answers on a calculator. It's pointless getting a question wrong when you can just check if you're right on your calculator. Now, something I didn't say in the previous question, but I should always check if this answer can be simplified. So I should say to myself, does anything go into 2 and into 9? Now, 2 only has factors of 2 and 1, and 9 isn't even. So 2 doesn't go into 9, and so it is in the simplest form. Also, you can put this in your calculator, and your calculator can check for you. But always check if that answer can be simplified. Okay, on to the next one. Our denominator, an LCD of 5 and 3 is 15, as far as I know, which means my answer is going to be a fraction over 15. Now there's a negative here, not a problem. It just means that this is negative to start with. So what do I do to 5? I have to multiply by 3. So what do I do to 3? I multiply by 3. So that's actually negative 9. I prefer to think of my negatives with the top, because I'm going to have to subtract now, and I need to use that negative sign. So don't let it bother you. 3 times 5 will give you 15, and 2 times 5 is 10. And so now what I have here is, remember, I leave the denominator the same, and my numerators is negative 9 minus 10 is negative 19. So it's actually easier to think of this negative as next to the 3, just so that when you add and subtract the numerators, it's a lot easier. Now let me check. 19 is a prime number, so that means nothing goes into 19, and I can't simplify that. I could write this as a mixed number, but remember, we don't bother. It's just a waste of our time. Check on the calculator to check it can be simplified, and check that we did this correctly, and hopefully we did. Okay, last example. What happens when there are multiple terms? So you're adding and subtracting in one question. Now, I think I've said this a million times this year, but probably the most important thing I will ever tell you is to divide into terms. Don't forget that terms are separated by plus and minus, and so I need to divide into terms. So this is 1 term, 2 terms, 3 terms. So there's 3 terms here. Now what I'm going to do is I'm going to simplify each term. That's what I normally do. Now for these questions, to be honest, most of the terms are simplified. And so then I can just go into subtracting and adding from left to right. So I don't have to actually worry about order of work. So add or subtract from left to right. We will get to a lesson where we're going to talk about order of work, but as long as we follow these particular steps, you pretty much can't go wrong. So we've divided into terms. We now need to simplify each term, and then we can add or subtract from left to right. Right, first thing, can I simplify any of the terms here? Well, this first term, interestingly, actually can be simplified. I don't have to simplify it, but I can, because 3 divided by 12, well, 3 goes into itself once, and 3 goes into 12 4 times. So if you wanted to simplify that, you can. My second term is 1/3, there's nothing to do there. And my third term is plus 3/4. Okay, now I've simplified each term. I need to add and subtract from left to right, and the only way to add and subtract is to have everything with the same denominator. And what is the same denominator of 4 and 3? The lowest common denominator is 12. Now, if you want to, instead of writing each of these fractions over 12, we start to get a bit tired when we have multiple fractions, so we just write one long denominator of 12. So you can do that, or you can divide each individual fractions into a denominator of 12. Either way, my last line is going to have a denominator of 12. Now, interestingly, look what happens. When I'm trying to convert this to a denominator of 12, I times 3 at the bottom and 3 at the top, and guess what? I go straight back to 3/12. So actually simplifying it was a little bit of a waste of time. So try to think ahead in future, like, should I be doing this? Okay, 3 needs to be multiplied by 4, so the top needs to be multiplied by 4, so that's minus 4. And then 4 needs to be multiplied by 3, so the top needs to be multiplied by 3, and 3 plus 3 is 9. So either you can do that, or you can write them as 3 minus 4 plus 9. You can actually write them as separate fractions. Now, I mean, you can use your calculator to help you here, but I would add these two together just because I find it easier to add. So what's 3 plus 9? 3 plus 9 is 12. 12 minus 4 is 8. So it's 8 over 12. So you can just go 3, take away 4 is -1, -1 plus 9 is 8. But I find it easier to add the positives together first. Okay, now last step, and we haven't had to do this step ever, but hang on, can't this be simplified? And I'd kind of left out space for this. Can this be simplified? And I think it can, because I know a number that goes into 8 and into 12. 4 goes into 8 and into 12. So if I divide the top by 4, 8 divided by 4 is 2. And if I divide the bottom by 4, 12 divided by 4 is 3. Now you can actually use your calculator to simplify that for you. If you put 8 over 12 in your calculator and push equals, you get 2/3. I won't know whether you thought about it in your head or not. So you can use your calculator if you'd like to. I would also pause in an exam and actually just put that question in my calculator and check if I got it right. It's an easy way to check. So just to recap our steps there, we divided into terms. We then simplified each term if necessary, and here we kind of realized we didn't have to. And then we add from left to right. And how do we add from left to right? LCD. And then don't forget, can your answer be simplified? Okay, let's try another one. Now again, I'm not going to be drawn in here to converting this 3 over 12, because if I look forward and I say to myself, hang on one moment, and if I have a look, oh gosh, look, it's exactly the same question. So let's skip our way down to C, because there's no point in doing the same question again. So let's skip down to C. We'll now call it B. Right, so first step was to divide into terms. We have 1, 2, 3 terms here. Now this is a really important question, because I'm hoping you notice here that first of all I've got a whole number. And whole numbers tend to mess people around because people get confused as to what is the denominator of a whole number. Remember that 2 is 2 divided by 1. Any whole number has a denominator of 1. Okay, a half is as simplified as a half is going to get. Now, very, very importantly, and this is one of the reasons why we do not like mixed numbers. Never, ever, ever add mixed numbers together. I know in primary school they taught you to add mixed numbers together by adding the wholes and adding the fractions. Now in primary school that worked because everything worked out to be a positive. You didn't have integers. In high school, but because we have integers, it is an absolute disaster to work with mixed numbers. So never ever work with mixed numbers. Convert them to improper fractions. Now this is probably the most important thing I'll say in this video, and I know it's counter to what your primary school probably told you. Never work with mixed numbers. Never add mixed numbers together. Don't add the wholes and add the fractions. Always convert to an improper fraction. Always. Otherwise, we actually start getting the incorrect answer. So always convert to an improper fraction. So in this case, let's quickly remind ourselves, if you have one whole, each whole being divided into 6 pieces, you'll have 6 pieces. So 1 times 6 is 6 pieces. And then 1 left over. So 7 pieces out of 6. So when we say simplify each term, that includes always convert a mixed number to an improper fraction. That's kind of one of the steps of simplifying each term. Really, really important. Now we're going to add and subtract. Now we said we would add and subtract only if we had the same denominator. So what's my LCD of 1, 2, and 6? Well, that's going to have to be 12. Again, you can write it all over 12, or you can put it into 3 separate fractions. Okay, so we said to ourselves, what do you have to multiply 1 by to get 12? So times 12. 2 times 12 is 24. Okay. Next one, what do you have to multiply 2 by? 2 times 6. So 1 times 6 at the top is 6. And last one, and I noticed, you see I made this into an addition as opposed to subtraction, because I'm pretty sure there's a subtraction in the question. So this should be subtract. And I'm multiplying 6 by 2, so 7 by 2, subtract 14. Leave the denominator the same. It is still 12. You don't subtract any of the denominators. And now 24 plus 6 is 30, and 30 take away 14 is 16. Now most importantly, and this is what people forget, does this simplify? Your calculator can help you. Let me write that better. Does this simplify? Your calculator can help you do this, or you can think to yourself, what goes into 12 and into 16? 4 goes into 16, and 4 goes into 12. 4 goes into 16 4 times, 4 goes into 12 3 times. Now notice I'm not converting that to a mixed number because, to be honest, we really don't like them in high school. So the whole reason I chose this example was, very importantly, always convert to an improper fraction. Never ever ever work with mixed numbers, even though they told you at primary school to do it. And that's simply because in primary school it worked, but with the integers in high school it doesn't. Okay, so just to summarize what this lesson was about, you can only add and subtract fractions when you have the same denominators, lowest common denominator. Then, if you get a question with multiple terms, divide into terms, convert all the terms to improper fractions, and then find your LCD and just add and subtract your tops. You don't actually have to worry about order here because you're just adding and subtracting. So you work from left to right. Hopefully that made a lot of sense, and hopefully it's a lot of, oh, I remember that from primary school, because we should have seen most of this before.